All right, good morning, everyone. We're going back to lesson 1, simplifying algebraic expressions. We're going to do most of these 2 pages. Let's start at the top, defining these terms and numbers in this expression. So let's start at the top. Both of these 3 boxes are the same. Each one of these, separated by a plus or minus sign, is considered a term. So we have 3 terms in this example. Let's go down here underneath. The little 2, that's the power or exponent. The 5 next to the variable is called, make sure you get this spelled right, coefficient. So also a coefficient is the 3. You see the arrows pointing to the 3 also because it has a variable next to it. So this box, the x is the variable. We will talk about that a number of times in the next 2 weeks. The 5 by itself has no variable next to it, so we're going to say that is a constant. It does not change. So those are your terms. Now, the important vocabulary, we're not going to fill this in because the examples will talk about the variable, the constant, the coefficient, the term, and the liked terms. So let's go down to the 3 examples. Example 1, let's see what we have. We have a 2a minus a 3b plus a 7a minus a regular 9. So the 2, the 3, the 7, those are our coefficients. The a, the b, the a are our variables, and that's a term, that's a term, that's a term, that's a term. So we have 4 terms. But it wants us to combine them. Now, you cannot combine an a and a b, but you can combine an a and an a. So I like to do little brackets because I'm going to combine the 7a and the 2a. That gives us a 9a. That's an a, by the way. Then I have, notice, I only have one variable of b, so I can't really combine it, so I'm just going to rewrite it here. Notice that's a minus 3b, and the 9, there's nothing to combine it with also, so I'm just going to rewrite it. So there's our simplified expression, and really we only did one thing, we combined the a. So let's go to example 2. There's a lot of terms here, 1, 2, 3, 4, 5, 6, 7 terms. I see there's a 1j, there's a minus j, 8j. I see there's a 2k and a minus k. So let's take the j's first. Now, here's the key. You've got a 1j minus an 8j. That is going to be negative 7j. So let's do that again. 1j minus an 8j. That's going to give us a negative. When we have terms this many, I want to go ahead and cross these 2 out because I'm done with those. Let's deal with the k's next. I've got a positive 2k minus a k. So that's going to give me a 1k. And notice I'm not going to put a 1 in front of the k because it's not needed, but it is a 1k. So what I did is 2k minus 1k gives me a positive k. So let's cross those out. And what I'm left over, don't forget about this 18 down here. 18 minus 7. Oh, you got a 24 also. I almost missed it. So 18 plus 24 minus 7. So 18 plus 24 minus 7. If you put that in the calculator, that's going to give you a plus 35. And that was a real long one. Notice I crossed out, again, the terms that I had already used, so I won't double up on it. So this one's also a long one, example 3, which is 4x. And I've got y's. Let's cross those out. I got a 9y plus a 3y. Now that's a negative 9y plus 3y, so that's going to give me a negative 6y. Let's cross those out. I'm left over with a positive 3 minus 8. That's going to give me a negative 5. So those are the examples on the front. Let's go to the back page. Now we're going to use our knowledge and create with images. we're going to find the perimeter of each expression. Now the perimeter is all the way around. So let's look at example 1. It's a rectangle. It's a rectangle. So I've got a 2x. Now they're not giving you measurements. They're putting expressions in there. So a 2x here. So I'm going to have a 2x over here. Opposite of the top side and the bottom side, I'm going to put 3x plus 7. Now we have it filled in. We have to find the perimeter. So what I'm going to do is something a little different, make it shorter. I'm going to take these 2x's. There's 2 of them. So I'm going to say 2 times 2x. And perimeter is always addition. So what am I going to add it to? I have to add it to these 2 sides. And these 2 sides are the same, so I'm going to do the same procedure. Now let's look at what I did. I took the 2 sides here, the 2x, and multiplied it by 2. Took the top and the bottom side, multiplied it by 2. So the distributive property gives me a 4x plus 6x, don't forget about the 7, plus 14. Okay, so I did distributive property here, and these are my terms now. Notice I have 2 x's here, so I'm going to make that a 10x plus 14. Some students want to add these two. You cannot, because 10 has a variable, 14 does not. It's a constant, so you can't add those two. That is simplified all the way down. Let's go to the triangle. All right, with the triangle, opposite sides don't work, that situation that we did with the rectangle. So what I'm going to do is just write it all the way out. I got a 5f for the height. The base is 5f plus 8. And this is the hypotenuse, or the slanted line. So I've got all those terms, 1, 2, 3, 4, 5. I'm going to combine all my f's. I have 3 terms. So that's going to give me 10 plus 7, 17. F, cross those out. I did not do that on the last question. 8 minus 2. That is going to give me a plus 6. So that is simplified all the way down. Let's go to the last one. This is a 5-sided figure. I'm going to do the same thing I did, same situation I did for question 1. I'm going to do down here. Notice I have 2 of these are the same. So I'm going to say 2 times y plus 2, 2 plus 2 times 2y minus 1, and then I have this side by itself. I'm going to put it on the end. So we're going to do the distributive property again. 2y plus 4. 2 times 2 is the 4. Distributive property here. Plus 4y, careful, minus 2. Positive 2 times is negative 1. Plus 3y. I still have all these terms. Look at the y's here. I have 3 terms with a y. So I'm going to add 2 plus 4 is 6, plus 3 is 9y. Careful with that minus 2. 4 minus 2 is plus 2. So there are your examples with shapes and expression and combining expressions.